A very good morning and afternoon to everyone who are watching this video. Before I start the presentation, I would like to start with my introductions. My name is Daniel Ferrana Sandai with matriculation number of KA24009. My group and I would like to present on an accident which is Phillips 66 chemicals complex explosion that occurred on October 23, 1989 in Pasadena, Texas. This tragic event led to 23 deaths, over 300 injuries, and 750 millions in damages. The explosion happened due to a gas leak and electrical factors like static electricity or spark from equipment might have caused the fire. This shows how important electrical safety is in hazardous environment. So we move to the next section of the presentation by telling you guys the main cause of the explosion, which is a gas leak due to poor maintenance of the polyethylene reactor. However, electrical issues worsened the situations. So the electricity likely built up because the plant lacked proper grounding system to safely dissipate charges. Without grounding, static can accumulate and create a spark in flammable environments. Faulty tools or wiring might have also contributed, creating spark that ignited the gas. Additionally, some electrical equipment may not have been explosion-proof, meaning it wasn't designed to safely contain spark in hazardous areas. This electrical hazard demonstrates how critical it is to ensure all systems are properly maintained and meet safety standards. Failure to do so can lead to the tragic outcomes like this. Last but not least, for my part, let's focus on how electrical factors were directly involved in this disaster. Static electricity built up in plant because grounding systems were either missing or not working efficiently. This build-up created a high risk for spark in flammable gas environment. An electrical spark, likely from nearby tools or wiring, is believed to have ignited the leak gases. Adding to the problem, some electrical equipments in the plant may not have been explosion-proof, which made it more likely for spark to escape and cause a fire. This incident reminds us of the critical needs for strong safety system, proper maintenance, and compliance with electrical standards, especially in high-risk industry like this. So, that's all from my part. I will move to the next section of the presentation, which is the related law, and also my other teammate, which is Bainun, will explain the solution for these incidents. So I think that's all from me. Thank you.
An oil refinery. A blast or a fire occurred at the Phillips 66 Company Houston Chemical Complex, Texas, occurred at October 23rd, 1983. The approximate time of this incident is around 1 p.m. Where it started due to a system failure. In this case, we found out that it's a storage tank where the valve was faulty, causing it to be open, which that storage tank was storing, very highly flammable processed gases. These gases form a vapor in the room, which soon find its way to an ignition source, which a source where it can start a fire. In this case, on the Phillips disaster, they found the TNT causing a huge explosion and fire. And on the picture here, right here, it's one of the picture that was captured at the incident. Safety feature. Not only the faulty system, which is the open valve, that contribute to this disaster, the lack of safety feature in the factory caused this a very avoidable disaster to a very devastating disaster. One of the lacking safety features is the lack of failsafe. Like for example, most factory nowadays they have this failsafe or isolation system where if anything happen, they can click it. This system will prevent this disaster from going out of control. So another issue that the Philips factory went through was the problematic water system. Water sprinkler system, which is on the right side, is like an example of a standard response sprinkler. The water sprinkler system wasn't operational, so they cannot isolate or prevent the fire from spreading, and also the water line nearby was ruptured because of the explosion, and electric cable that was destroyed by the fire also contributed to this disaster. So some of the related laws and standards that we were able to find, we go through the law first. General Duty Clause. This is an OSHA Act at 1970, which this clause or law was already implemented before the Philips disaster happened, where an employer need to create a safe workplace. So what does it mean to be a safe workplace? Where it's free from recognized hazard. For example, this one, like on the Philips disaster, where a very flammable gases was stored in the same location or nearby to an ignition source. I'm sorry. So so we go through the standard, which is also both of them are OSHA standard. Again, it's about employers, which is your boss. Employers needs to implement a comprehensive process safety management system to prevent the release or accidental discharge of highly hazardous chemical. In this case, the unclosed valve in a storage tank release highly flammable gases, causing this disaster to occur. And we go through another OSHA standard, flammable and combustible liquid standard, which it requires employers to store, handle, and use flammable and combustible liquid safely.
Assalamualaikum and hello everyone. My name is Siti Bin Muhammad. My matrix number is 24054. From the incident's Philips disaster, here are the electrical safety precautions that every workplace must implement to prevent electrical accidents and ensure worker safety. First, ground all electrical equipment. Grounding is essential to safely dissipate static charges that can build up in hazardous environments. Without proper grounding, these charges could cause sparks and will leading to fires or explosions. Second, use explosion-proof electrical tools in areas with flammable gases or vapors. It's vital to use equipment designed to prevent sparks. Explosion-proof tools are specifically engineered to operate safely in these high-risk settings. Third, regularly inspect and maintain wiring and equipment. Over time, wear and tear can compromise the safety of electrical systems. Routine inspections help identify issues like damaged cord, loose connections, or faulty wiring. ensuring they are addressed before causing harm. Fourth, implement lockout takeout, or we call LOTO procedures. LOTO is a critical safety process that ensures equipment is completely de-energized and isolated during maintenance. This prevents unexpected energy releases that could harm workers. Finally, provide workers with comprehensive training. Proper training is the foundation of workplace safety. Workplace must be equipped with the knowledge to handle electrical tools correctly, identify hazards, and follow established safety protocols. By following this preventive measuring, we can minimize risks, protect life, and maintain a safer workers.
Thank you for listening.